Hi everyone, so here we're going to get into the meat of atoms and pretty much what they're made up of. You'll need your notes, which is your pen and paper. We're going to talk about protons, neutrons, electrons, and then go through some practice questions. So, protons. Protons are going to have a positive 1 charge, or it's a positively charged plus 1 charge. It has a mass of 1 AMU. So if you take a look at your reference table, AMU stands for atomic mass unit. The location's in the nucleus. And if you change the number of protons, you change the element completely. The periodic table is based upon the number of protons in an atom. So if carbon, for example, has 6 protons. So if you made it 5 protons, well, it would actually be the one before it, boron, instead. The notation, and this is from Table O, so make sure you take a look at Table O in case you don't know how to do this one, or in case you forget it. It's 1 over 1 H or 1 over 1 P. So if we remember for the isotope, if we take a look at these notations, we have 1, 1, H. The H stands for a hydrogen atom, or hydrogen, excuse me. The 1 stands for, the 1 at the top, excuse me, stands for the mass. And the 1 at the bottom stands for the number of protons or atomic mass. Excuse me, atomic number, not atomic mass. So we see here that it has 1 proton down here, and has a mass of 1. And the symbol, and this is how I generally write it, whoopsies, it'd be P plus 1. And so let's get that in there. So whenever you see me write anything about a proton, it's P with a superscript plus. And that, since there's no number there, it's assumed that there's a 1 there. Neutrons have a charge of 0. They're neutrally charged. They have a mass of 1 AMU. They're also in the nucleus as well. Don't forget that they help offset the positive charges of the protons. If you change the number of neutrons, you actually change something called, or change it into something called an isotope. So if you have a different number of neutrons, it changes the isotope. And we'll discuss isotopes pretty soon. The notation is 1, 0, N. N stands for the neutron. So we have 1 at the top. That's going to be the mass. 0 is the number of protons. There's not really the protons in the neutrons. And the N, of course, is for the neutrons. The symbol is going to be N with a little 0 above it, standing for that's going to be neutral. Electrons have a charge of -1. They're negatively charged. Their mass is so much smaller than a proton or a neutron that we don't even consider it. So it's like 1 over 2,000 AMU. It's so teeny tiny. So we don't really factor that into the masses. They're located in orbitals. We saw that from the wave mechanical model. If you change the number of electrons, you change its ions. So we've seen something called cations and anions. We'll go more in depth with that in section 4. And whenever I draw electrons, I just draw them out with the E for electron and a negative charge. That stands for -1. So let's go through some questions here. Which two particles each have a mass approximately equal to 1 atomic mass unit? So we want to figure out which one has a mass of 1 AMU. We have electrons and neutrons, protons and neutrons and all that sort of stuff. So let's kind of make sure that we remember. Electrons, that was the most recent, that has a charge of 1 over 2,000 AMU. And it's about 1 over 2,000. Really, it's like more over, like 1 over 1,876. So there's different estimates. You might see a bunch of different ones. Protons have a charge of a mass of 1 AMU. And neutrons have a charge, I keep saying that, a mass of 1 AMU. So we want to get rid of anything that has electrons, so we want to make sure it's protons and neutrons. There we go. The next question, the mass of 12 protons is equal to, so if we have 1 proton, that's equal to 1 AMU. So if we have 12 protons, that should be equal to 12 AMU. So we should make sure we look through here, 12 atomic mass units. And in case they asked if they didn't have atomic mass units, they might have asked about like neutrons. So if you're here for B, you see the mass of 1 electron or the mass of 12 electrons. If these were neutrons instead of electrons, think about which one would have been correct. And that one would have been C, the mass of 12 neutrons is equal to the mass of 12 protons, because they each have 1 AMU. They're the same mass. What is the net charge of an ion that has 9 protons, 11 neutrons, and 10 electrons? So let's think about what all of these charges are. 9 protons, so 9 positive charges. 11 neutrons. Now, they don't have any charge whatsoever, so they shouldn't be factored into any charge. So don't worry about them. and then 10 electrons. So electrons have a negative charge, and there's 10 of them. So in fact, let's do this. 9 minus 10 should give us a negative 1. So let's go ahead right there. The way that they're going to try to trick you is putting in those neutrons. They want you to assume the neutrons have something to do with the charge. It doesn't, because it's neutral. Alright, an atom is electrically neutral because, and now here, we want to know why it's overall it's neutral. So for A, the ratio of the number of neutrons is to the number of electrons is 1 to 1 ratio. So if we had a charge of 0, that's not going to be the same charge as negative 1, which is the electrons. For B, the ratio of the number of neutrons to the number of protons is 2 to 1. So again, a charge of 0 to a charge of plus 1, that doesn't factor in there. The number of protons equals the number of electrons. Sure, if you have 12 protons equal to 12 electrons, then yeah, that should overall balance each other out. Let's see. And then the number of protons equals the number of neutrons. So since the neutrons are neutral, they have 0 charge in them, they wouldn't have any, they wouldn't balance out the number of protons. So C is your answer here. Alright, and let's take a look at this question. What is the total number of electrons in an atom of potassium? Now this one, you'll actually need your periodic table. So if we want to figure out the number of electrons in an atom of potassium, let's take a look at potassium. Its symbol is K. So let's look at the key itself. Upper left shows you the atomic mass. This is your symbol. This is your atomic number, which is also equal to the number of protons. And we'll learn that in the next video. And the electron configurations in the lower left. So really, they have 19 protons. So they should have 19 electrons in an atom. So an atom is neutral. The number of protons is equal to the number of electrons. And the next question, what is the total charge of the nucleus of a carbon atom? So let's find carbon, which is right here. And we want to know what the nucleus is. So remember, the nucleus is made up of protons and neutrons, but we just want the charge, so neutrons don't have any factor in there. So we just want the total number of protons in a carbon atom. So since we have carbon here, we know that there's 6 protons in there, so it should be a plus 6 charge. Don't go for that negative 6, that's the number of electrons. Alright, so again, protons are positive. You might also see them later on called atomic number. That's how they're written out on the periodic table as well. Neutrons are neutral, electrons are negative. Make sure you do remember the masses as well as their locations and their symbols and notations. Have a great day, guys.